Welcome to our deep dive today. We're going to unpack how choices about things like wireframes, microservices, API design,
Yeah,
all of that can actually make or break the user experience.
totally.
It's like those little design things that make you go, wow, that's so smart when you use an app. Like, you ever would wonder how developers make those multi-step forms not a total pain on your phone?
Right.
We're getting into that. Our expert actually mentions this financial services company that had to get seriously creative with their code to avoid a UX disaster.
Yeah, it's all about finding that sweet spot, right? Where the user experience is smooth, but the technical side of things is, rock solid.
Okay, let's jump into this first question. It comes up a lot in the beginning stages of software design. So you've got your wireframes, which are like the blueprints for your app's look and feel.
Yeah.
And then you've got the actual HTML structure, the code that makes it all work.
Right.
So how do you make sure those two things work well together without sacrificing a good user experience?
So our expert really stresses how important it is to approach those wireframes with a deep understanding of the user's journey. So imagine you're the user using the app for the first time.
Okay.
What are you trying to do? Where might you get stuck?
So before you even sketch out that first button or input field or whatever, you've really got to walk a mile in your user's shoes.
Exactly. Once you have that user journey figured out, then you can start thinking about the visual layout and then finally the HTML structure that makes it all work.
Makes sense. But what happens when those initial wireframes, even if they're super user-focused, what happens when they hit the realities of HTML and coding and all those limitations?
That's where it gets interesting. Collaboration is key here. Our expert talks about this case study. It was a customer onboarding system for, I think it was a financial services company. They designed this really sleek, user-friendly, multi-step form. But then when it went to the developers, let's just say the HTML structure they chose at first, well, it wasn't great for mobile responsiveness.
Ouch. Yeah. Big problem these days when everyone and their grandma is glued to their phone.
Exactly. So they had to go back, tweak the wireframes, find these creative workarounds in the HTML to make sure that form worked perfectly on any device.
It's like this constant dance between design and development, making sure everyone's on the same page. Okay, let's switch gears a bit and talk about microservices. It's a hot topic in software development these days. How do you even decide where to draw the lines between these microservices? It's got to be more than just chopping up a big application into smaller pieces, right?
You're totally right. It's not about making it smaller. It's about making things smarter and more independent. Our expert emphasizes how important it is to first understand the core functions of your application. So what are the essential building blocks of your system?
So it's like figuring out the individual ingredients in a recipe before you even start mixing them together.
Exactly. Once you've identified those core functions, then you can start designing microservices that each handle those functionalities. Like, think of building with Lego blocks. Each block has a specific purpose, and then you combine them to create something larger and more complex.
Okay, I'm starting to see how this all fits together. But those Lego blocks have to talk to each other somehow, right? How do you make sure these independent microservices can all work together smoothly as one system?
That's where having really clear communication protocols is super important. Just like in a well-run team, each microservice needs to know exactly what information it's responsible for, how to share that information, and how to understand requests from other services.
So it's about establishing clear boundaries, but also making sure there's smooth communication across those boundaries.
Exactly. And to kind of illustrate this, our expert uses the example of an e-commerce system. They were able to separate this system into microservices for things like payments, product management, customer reviews.
Oh, okay.
This approach let them scale each service independently, like adding more checkout lanes in a busy store.
Smart.
And the result, better performance and a smoother experience for the users, especially during those peak traffic times.
That makes a lot of sense. If one part of the system gets slammed, the other parts can keep chugging along.
Yeah.
No more website crashes on Black Friday.
Right. Yeah, exactly. Speaking of keeping things running smoothly, let's talk about something that I'm sure a lot of development teams struggle with, that whole debate of single-page applications, SPAs, versus multi-page applications, MPA.
The classic SPA versus MPA dilemma.
Right?
It's like choosing between a sleek sports car and a reliable SUV. They both have their strengths.
Exactly. Our expert really emphasizes that the best choice depends totally on the project. Are we going for those super fast loading times, that app-like feel? Or is it more about SEO and making sure it's easy to navigate?
So even before you start writing code, you have to know what the project goals are, what matters most to the people who are actually going to use it.
Exactly. Now, when it comes to the user experience, SPAs often come out on top. They've got that smooth, almost instant transition between sections, like when you're scrolling through your social media feed and it just keeps going.
It's that I need it now mentality that seems to be taking over the internet.
Yeah.
People expect things instantly.
Yeah, exactly. But MPAs have a trick up their sleeve. They're generally better for search engines, which is a big deal for businesses if they want people to actually find their website.
Right, because each page in an MPA has its own URL, so it's easier for Google and those other search engines to do their thing, crawl the site, and understand the content.
Exactly. And for applications that are bigger, have a lot of content, MPAs often perform better because each page loads separately. It's like having different compartments in a ship. Even if one part floods, the rest can stay afloat.
Okay, so SPAs for speed and that app-like experience. But if SEO and handling tons of content are super important, MPAs might be the way to go.
Exactly. And let's not forget about the developers who are actually building these systems. SPAs can get pretty complex. They often need these JavaScript frameworks that can take a while to learn.
It's all about using the right tool for the job, right? Sometimes it might even be a hybrid approach, using a bit of both SPAs and MPAs.
Exactly. There's no one right answer when it comes to choosing the right architecture. It's all about really analyzing what the project needs, understanding the technical compromises, and then making a decision that aligns with those big picture goals.
Okay, so speaking of analyzing complex processes, let's talk about BPMN diagrams, those visual representations of how a business process works, step by step. How can a business analyst make sure those diagrams actually represent all the twists and turns of a complex workflow?
So our expert says it's really important to think beyond just the happy path scenarios.
Wow.
You can't just map out the ideal situation. You have to anticipate those edge cases, those what-if situations that could totally throw things off track.
So it's like creating one of those choose-your-own-adventure maps with all the unexpected detours and different endings.
Yeah, exactly. And to really capture those complexities, our expert suggests using a bunch of different BPMN elements, like gateways, for example. Think of those roundabouts you see in Europe. They can represent decision points in the process.
So depending on the type of gateway, it could either send the process down a specific path or offer multiple paths based on certain conditions.
Exactly. And then you've got events, which can be things like exceptions or outside triggers that might change how the process goes.
It's like planning for those surprise road closures or detours that life throws at you. Sometimes you need a plan B.
Exactly. Once you've got this detailed diagram figured out, the next step is to get feedback from both the business and technical teams. The business people can make sure the logic of the process makes sense, and the tech team can check if it's actually possible within the system.
It's like having both the pilot and the mechanic check out a plane before takeoff.
Yeah.
You need those different perspectives to make sure things run smoothly.
Exactly. And our expert really emphasizes that this validation shouldn't be a one-time thing. It's got to be an ongoing process of feedback, making things better, even simulations to make sure that BPMN diagram is as accurate and as strong as it can be.
Because just like with software, business processes are rarely set in stone. They're constantly changing.
Absolutely. Now let's address the elephant in the room. Those unexpected things that can really mess up even the most well-planned projects. What happens when a new software architecture standard pops up right in the middle of a project?
Oh man, that sounds like the worst. I can already feel the stress levels rising.
Yeah, it's definitely not ideal, but it's something that a lot of teams have to face sooner or later. Our expert suggests staying calm and collected. First step, figure out the impact. Work closely with both the technical team and the people in the business to see how this new standard will actually affect what you've already designed.
So it's like assessing the damage after an earthquake. You need to understand how bad it is before you can start rebuilding.
Exactly. Once you have a clear idea of the impact, communication is key. Clearly explain the potential benefits and risks of using this new standard to everyone involved. What are the trade-offs? What are the potential challenges?
It's about making sure everyone's on the same page, understands the situation, and can make good decisions about how to move forward.
Exactly. And when it's time to actually make those changes, our expert recommends an iterative approach. Don't try to do everything at once. Break it down into smaller, more manageable steps.
So instead of this huge, overwhelming overhaul, it's more about strategically integrating those changes over time.
Exactly. This way, you're minimizing disruptions to the work that's already happening, and it gives you more flexibility to adapt to those inevitable surprises that pop up along the way.
It's about rolling with the punches, being adaptable, and adjusting to the ever-changing world of software development.
Precisely. And to illustrate this, our experts shared a story from their own experience. They had to integrate a new cloud-native architecture standard in the middle of developing a financial application. No easy task.
Wow, that sounds really challenging.
Yeah.
How did they manage to make it work without throwing the whole project off track?
They realized that doing a complete overhaul at that point would be way too disruptive and risky. So they went with a phased approach, strategically implementing certain parts of the new standard while sticking with the original plan for other parts of the system.
It's like renovating a house while you're still living in it. You can't just tear down all the walls at once. You have to find a way to live with the mess while still making progress.
Exactly. It's about finding that balance between embracing new ideas and keeping things stable. Now, let's switch gears a bit and talk about APIs, those application programming interfaces. They're like the connectors that let different systems talk to each other.
Yeah, exactly. In a world where there's an app for everything, APIs are super important. Just think, when you use your social media account to log into a shopping website, that seamless experience is all thanks to APIs working behind the scenes.
Precisely. To give us a peek into the world of API development, our expert shared a story about a project they worked on for a financial services company. They were building an API to integrate a new payment processing system, a pretty crucial part of any business that handles online transactions.
That sounds like a tough one, especially with all the security and compliance rules around financial stuff. What were some of the big things they had to keep in mind?
Well, first and foremost, they had to make sure the API's functionality lined up perfectly with what the company needed. That meant getting everyone together, product owners, developers, compliance teams, to really nail down those requirements.
So again, it's that all-hands-on-deck approach, making sure everyone has a voice and their needs are taken care of.
Exactly. And to bridge the gap between the technical side of building the API and what the business actually needed, our expert used a really cool tool, prototyping.
Ah, prototyping. We've seen how helpful it can be in different situations. How did they use it for API development?
They used these tools to basically create mock-ups of the API, like simulations of real-world situations. This way, they could see how the API would handle different requests, process transactions, and deal with errors, all before writing any of the actual code for the real API.
It's like building a model of a building before you start pouring concrete.
Right.
You can test things out, find potential problems, and make changes early on before it's a huge headache to fix.
Exactly. And speaking of avoiding headaches, our expert stresses how important it is to manage expectations throughout the whole API development process.
That's key because sometimes people who aren't as familiar with the technical side of things might not understand all the complexities and limitations.
Exactly. Our expert is all about transparency. If a certain feature can't be done right away, or if they have to make some compromises, they communicate those decisions clearly to everyone involved. They explain the why behind it and explore different options.
It's all about building trust and making sure everyone's in the loop.
Absolutely. And to manage expectations even better and make sure the launch goes smoothly, they create super thorough documentation. This documentation is like a guide to the API, explaining what it does, its limits, and how it's supposed to behave.
It's like a user manual, so anyone using the API knows exactly what they're doing.
Exactly. And what was the result of all this careful planning, communication, and user-focused work? The API launched successfully and not only met, but exceeded what the business wanted. Everyone was thrilled.
That's amazing. It just goes to show that building a truly great API isn't just about being a coding whiz. It's about really understanding your audience, managing expectations, and communicating clearly every step of the way.
Well said. Now, let's talk about something that can make both developers and business stakeholders a little uneasy. What happens when someone suggests switching from a layered architecture to an event-driven architecture right in the middle of a project?
Oh boy, that sounds like a pretty big change. It's like deciding to rearrange all the furniture in your house while you're hosting a party.
It can definitely feel that disruptive, and as you can imagine, a decision like that can have a ripple effect on the entire project.
So where do you even begin to figure out what a change like that would mean?
Our expert says to start with a thorough analysis of the impact, focusing on two main areas: business processes and how users interact with the system. How will this architectural shift change the way people work and use the system?
Right. It's about understanding the human impact, not just the technical details.
Exactly. And when you're analyzing those potential impacts, it's crucial to acknowledge both the good and the bad. Event-driven architectures are known for being scalable, responsive, and flexible.
So it's like upgrading from a bicycle to a high-performance motorcycle. You gain speed and agility, but it might take some getting used to.
That's a great way to put it. But just like with any powerful tool, there's a chance things could get more complex. Managing those event streams, making sure the data is consistent, and troubleshooting problems can become more challenging.
So it's not a decision to be made lightly.
Definitely not.
Um,
That's why clear communication is so important. Our expert really emphasizes documenting everything in a way that both technical and non-technical people can understand.
because in the end, it's about making informed decisions together as a team.
Exactly. And when you're communicating these findings, try to avoid using too much technical jargon. The goal is to give people the information they need without overwhelming them with technical details.
It's about meeting people where they are and speaking their language.
Precisely. And sometimes words just aren't enough. Visual aids like diagrams and flowcharts can be super helpful for explaining complex ideas, especially when you're comparing two different approaches.
It's like giving people a visual roadmap to help them navigate this new architectural landscape.
Exactly. Once everyone has a good understanding of the situation, create a space for open and honest discussion. Encourage people to ask questions, address their concerns, and make sure everyone feels heard.
Collaboration and open communication are key for navigating big decisions like this.
Absolutely. Since this kind of shift can be pretty complex, our expert recommends taking an iterative approach to implementing it.
So instead of flipping a switch and suddenly everything's different, it's more about taking things one step at a time, testing things out, and making adjustments along the way.
Exactly. This could mean trying out certain parts of the event-driven architecture before rolling it out to the whole system.
That makes sense. You can get real-world feedback and deal with any unexpected problems in a more controlled environment.
Precisely. Our expert actually showed a great example of this in action. They were part of a team that was moving a customer relationship management (CRM) system to an event-driven architecture.
Oh, I'd love to hear how they handle that. CRMs are often at the heart of a business, so any big changes can have a huge impact.
Absolutely. Well, they started by carefully documenting how they were currently processing leads, which was initially done in a more traditional step-by-step way.
So they created a starting point, a clear picture of how things worked before.
Exactly. By mapping out that existing process, they could see where the bottlenecks were and what wasn't working as well as it could. This helped them build a strong case for why an event-driven approach would be better, showing how it could improve things like response times and lead nurturing.
It's about focusing on the why behind the change, not just the what.
Precisely. They were able to demonstrate how this technical change could actually have a real positive impact on the business.
That's awesome. They showed how this change, which might seem purely technical, could actually bring real value to the business.
Exactly. And while they did run into some technical hurdles along the way, like making sure the data was consistent across those event streams and setting up really strong monitoring systems, everyone involved stayed supportive.
That just shows you the power of clear communication and showing the value of the change.
Absolutely. Speaking of crucial components, let's move on to a topic that's near and dear to my heart, data. Specifically, let's talk about building a new database for a customer management system.
The database.
Sure.
The heart and soul of any good CRM. That's where all that valuable customer information lives, gets organized, and hopefully helps businesses make smarter decisions.
Exactly. But designing and building a database that can handle all that information is no walk in the park. You have to gather requirements from all sorts of different people, sales, marketing, customer support, each with their own needs and ways of working.
It's like trying to design a house that makes every single family member happy. Quite the challenge.
A very accurate analogy. So, how can a business analyst make sure the database design works for all these different perspectives and workflows, while also setting the stage for a system that's scalable, efficient, and provides valuable insights?
Well, based on what we've talked about so far, I'm guessing it involves a good amount of process mapping, data modeling, prototyping, and a whole lot of testing.
You hit the nail on the head. It's about using all those tools and techniques strategically and collaboratively.
So where do you even begin? What's step one in this database design adventure?
Our expert suggests starting by really diving deep into the current situation.
Yeah.
How are stakeholders currently using the customer management system? Or how are they managing without one if they don't have one? What's causing them pain? Where are the bottlenecks? And most importantly, where are the opportunities to make things better?
It's like getting the lay of the land before you start drawing up the blueprints.
Exactly. A great way to get that understanding is through process mapping. Visually represent those existing workflows, whether you use flowcharts, diagrams, or whatever works best for your team.
Because sometimes seeing those processes visually can reveal things you wouldn't have noticed otherwise, like hidden connections, areas where things are being done twice, or places where things could be improved.
Exactly. And when you're mapping out those processes, make sure to involve people from every department. They're the experts in their areas, so their input is super valuable.
Right. The last thing you want is to design a database that looks perfect on paper but doesn't actually work in the real world.
Exactly. Once you have a good understanding of how those workflows currently operate, you can start thinking about the data itself. What information needs to be stored? How should it be organized? And who needs access to it?
Right, because a database is only as good as the data it holds and how easily people can access and use that data.
Precisely. That's where data modeling comes in. You're basically creating a blueprint for your data warehouse, defining the tables, fields, relationships, and rules that will determine how that data is stored and retrieved.
It's like designing the layout of a library. You need to think about how the books will be categorized, where they'll be shelved, and who can access which sections.
That's a great analogy. Just like with process mapping, getting stakeholders involved in the data modeling stage is super important. They can offer valuable insights into the specific data points that matter most to their work.
Because what might seem like a tiny detail to one team could be absolutely crucial information for another.
Absolutely. Once you've got a draft of your data model, it's time to bring it to life, at least in a simulated environment, through prototyping.
Ah, prototyping. We've talked about how useful it can be for things like API design. How does it work for databases?
It serves the same purpose, to create a tangible, interactive representation of the system early on. This allows stakeholders to actually interact with a simplified version of the database and give you their feedback.
It's like building a scale model of a bridge before you start constructing the real deal. You can experiment with different designs, spot potential problems, and make changes early on when it's much easier and less disruptive.
Exactly. And there are tools out there that make it pretty quick and easy to create these database prototypes, even if you're not a coding expert.
So you don't need to be a master architect to start experimenting with different database designs.
Exactly. The feedback you get during this prototyping phase is super valuable. It can help you identify potential issues, get everyone on the same page about requirements, and fine-tune the design before you spend a ton of time and resources building the actual database.
It's way easier to make changes on a blueprint than it is to demolish and rebuild a concrete structure.
Exactly. Once you've taken that feedback into account and refined the design, you're almost ready to start building. But before you jump into development, there's one more crucial step: validation.
Validation, that final check to make sure everything's good to go. What does that involve when it comes to database design?
It's about making sure the database design is not only functional, but also efficient, scalable, and robust. This means thoroughly testing the structure and performance of the database to find any potential bottlenecks or problems that might pop up later.
So you're basically putting the database through its paces, making sure it can handle real-world scenarios.
Exactly. There are a few key parts to database validation. First, you want to make sure the design follows the principles of normalization.
Normalization, I've heard of that. Can you remind me what that is and why it's so important?
Of course. Normalization is all about organizing the data in a way that minimizes redundancy and ensures data integrity. It involves breaking down big tables into smaller, more focused tables and defining relationships between them.
So instead of having one massive table with all the customer information crammed in, you create separate tables for things like customer demographics, contact info, order history, and so on, and then connect those tables in a logical way.
Exactly. This not only makes the database more efficient in terms of storage space, but it also helps prevent data inconsistencies and errors.
Right, because if you have the same information stored in multiple places and one of those pieces of information gets updated, you could end up with conflicting data, which can create all sorts of problems.
Exactly. Normalization helps reduce that risk.
Got it. So normalization is about efficiency and making sure the data is accurate. What about scalability? That seems pretty important too, especially with so much data being generated these days.
You're absolutely right. A database that runs perfectly with 1,000 customers might completely fall apart with 1,000,000 customers if you haven't considered scalability in the design.
So you need to design a database that can grow and change along with the business.
Exactly. There are different ways to build scalability into the design, like using indexing to speed up data retrieval or splitting the data across multiple servers to distribute the workload.
It's like designing a building with the ability to add more floors or expand the foundation if you need to in the future.
Exactly. And finally, you want to do some performance testing.
Right, because even a perfectly normalized and scalable database isn't much use if it takes forever to get the information you need.
Exactly. Performance testing is all about simulating real-world scenarios, like a bunch of users accessing the system at the same time to see how the database handles the pressure.
So it's like putting the database through a stress test to make sure it's ready for prime time.
Exactly. This helps identify any bottlenecks or areas for improvement. Once you've tackled normalization, scalability, and performance testing, you can relax a bit and move on to the actual development phase, feeling confident that you've built a strong foundation for your database.
That's reassuring. But even with the most carefully designed database, it's important to remember that your work isn't done once it's up and running.
Absolutely. Even the best databases need regular maintenance and optimization.
Because the needs of the business are always changing, which means the database has to keep up. It's an ongoing process.
Exactly. Speaking of which, our expert shared a great example of how they used these principles when they were designing a customer database for a retail company. They started, as always, by talking to the stakeholders.
There's that emphasis on understanding user needs again. What did they learn from those conversations?
They found out that they needed fields for things like customer demographics, purchase history, and past interactions, all really useful data for both sales and marketing.
Right, because that information can help them create more targeted marketing campaigns, personalize customer interactions, and ultimately boost sales.
Exactly. By carefully mapping out the workflows of both the sales and marketing teams and testing their design with prototypes, they were able to create a database structure that worked well for both departments.
They found that sweet spot, a database that could support both targeted marketing campaigns and efficient sales tracking.
Precisely. And they didn't stop there. To make sure the database could handle the demands of a busy retail environment, they even did load testing, simulating those crazy shopping days like Black Friday and Cyber Monday.
They were determined to make sure the database could handle anything.
Exactly. And because of their meticulous planning, collaboration with stakeholders, and thorough testing, they were able to create a truly exceptional solution. The database not only met the needs of the business, but actually surpassed their expectations.
It just goes to show you the power of putting the user first, working together, and using an iterative development process.
Absolutely. It's amazing how those same principles, putting the user first, collaborating, and iterating, apply to so many parts of making software.
It's like they're the foundation of building great software, no matter what specific technologies or methods you're using.
Exactly. And speaking of foundational elements, one key takeaway from today is that even small decisions, like how you structure your wireframes or decide what goes in each microservice, can have a huge impact on the user experience.
Yeah, it's like those tiny design choices in a car, like where they put a button or how the steering wheel feels. They might seem small on their own, but they all add up to the overall experience of driving the car.
Right. And just like with those car design choices, the choices you make when designing software should be intentional and focused on the user.
So as we wrap up our deep dive today, what are some key takeaways our listeners can use in their own work, whether they're deep in database design, figuring out those architectural changes, or creating those smooth APIs?
Well, if there's one big theme that's come up today, it's how incredibly important it is to understand your users. Really put yourself in their shoes. What are they trying to do? What's frustrating them?
It's about having empathy for the people who will be using the software every single day.
Exactly. And that empathy should guide every decision you make, from the very first wireframes to the last lines of code.
And of course, communication is essential. Break down those walls between departments, get stakeholders involved right from the start and keep them in the loop, and create a culture where everyone feels comfortable speaking up and sharing their feedback.
Absolutely. When everyone's on the same page and communication is flowing, you're much more likely to spot potential issues early on, avoid having to redo a bunch of work, and ultimately create something that truly meets the needs of the users.
And lastly, don't be afraid to embrace that iterative approach, making small improvements and adjustments as you go.
Exactly. The world of software development is constantly changing. New technologies pop up, requirements shift, and what works today might not be the best solution tomorrow.
It's about being adaptable, learning from those inevitable bumps in the road, and seeing challenges as opportunities to grow and innovate.
Exactly. By embracing those core principles, focusing on the user, communicating effectively, and being iterative, you'll be well prepared to handle anything that comes up in the world of software development.
Couldn't have said it better myself. Well, there you have it, your deep dive into building software with the user at the center. Who knew that even database design could be so interesting when you think about it from both the technical side and the user's perspective?
Absolutely. And as we've explored all these different aspects of software development, one thing's become clear. Even with the most complex systems, focusing on the why, What the business needs and what will make a great experience for the user is what ultimately leads to success.
Couldn't agree more. But here's something to think about as you go back to your own work. If the goal is to make the user experience super smooth, where do you draw the line between delightfully simple and just plain too simple? Finding that balance can be tricky.
That's a great question. It's definitely a fine line and one that's worth thinking about carefully.
And on that note, we'll wrap up today's deep dive. Thanks for joining us on this journey of exploration and discovery.